right, guys, I believe we finished these two problems yesterday, yes? Yeah.
I don't think we did.
Yep.
Oh, wait, no, we skipped. Oh, wait. Oh.
Did we not do 5 and 6?
No, we just skipped it.
Okay, yeah.
We did.
Yeah, because I think at that point we felt comfortable with writing set, or graphing set builder notation. So, what we're looking at is this here. We're writing each of these in set builder notation. Now, when we write it in set builder notation, we need it to be as kind of an inequality. We need to write the description as an inequality. We can't have it as an interval. Like B, problem B is in an interval notation. We can't just stick interval notation and set builder together. They don't go together. So if it was already as an inequality or greater than less than symbols, it's already written as an inequality, we can just throw it straight into set builder notation. We're good to go. If it's not, we have to write it as an inequality. So when we look at this first one here, the set of all integers greater than 5, there's two key pieces we need to be able to write in set builder notation. One is we need to know the type of numbers we're talking about. Here, the type of numbers that we're talking about are integers. So we're talking about the integers. Our description is going to be greater than 5. So we're talking about the set of integers greater than 5. So we could go on and start writing this because it'd be brace x. If it had been the set of real numbers, we can immediately put our bar, our such that. But since we're not talking about the real number systems, we're talking about the integers. So we're saying that x is an element of the integers. Such that x is in the integers. X is an integer such that we need our description. And as much as we want to just say greater than 5, we need to write this as an inequality. So greater than 5 tells us that whatever our number is, that's going to satisfy this has to be greater than 5. So we would put x and then our what? Greater than symbol and then 5, because x is greater than 5. That's the description for it. Questions on how we found the inequality? Well, we can fill that right in. X is greater than 5. And that's it. Questions on how we wrote that? Now, there are other ways we could have written this. Because we actually could have started out brace x bar, the set of all real numbers x, such that x is an element of the integers and x is greater than 5. It's saying the exact same thing, but there's just a lot more to it, yes? Both of these are saying the exact same thing. There's nothing really different from them besides visually what we're seeing. They both say the same thing. You don't have to put both of them. I only need one of them. Now, big ideas does it or writes it a little bit differently. You don't have to write this one because I think this is a bit much. Because they say the set of all real numbers x such that x is an integer and I think that's writing way too much. There's so many easier ways to do it. They literally write it out each time, or they do it the way above it. I think the top way works just fine. And I show you this to see that there is more than one way we can write this. But we only have to write it one of them. I think we prefer the first one, yes? Yeah. Questions on A? We feel good with this here? Yes, no? We good? We want to see a few more? No? Let's look at B. So we have parentheses, negative infinity, comma, negative 1 parentheses, or parentheses, negative 1 comma infinity parentheses. Here we have intervals. Now, did they specifically tell us what number type we're talking about? Well, no, but yes. Because unlike the first one, they didn't say the integers or the real numbers or the rational numbers. But because we're talking about an interval, we are talking about the real numbers. We're talking about all the numbers from negative 1 to negative infinity. We want all of them. So we want all the real numbers. So our real number system is the type of numbers we're talking about. And our description are these intervals here. Now we need to rewrite each of these intervals as an inequality. So this first one here, we're saying all the numbers from negative 1 to infinity. Really, this is saying all the numbers less than negative 1 will work. Yeah? So inequalities will have variables. Inequalities, our inequalities equations will have a variable. Our interval notation will not. So we're saying what? X is less than negative 1 because we're going to the left. We're going to negative infinity. We want the values of x that are smaller than negative 1. For this statement here, could x be negative 1? Could it be equal to it? Because if it is, we need to look at the symbol after the negative 1 or next to it. If it's this bracket, it's included. If it's a parenthesis, it's not. So here, do we have a parenthesis or a bracket? Parenthesis. So we cannot have it equal to it. It's just going to be less than. Questions on our first inequality before we look at the second one. Let's find the second one. So here we're saying we're going from negative 1 to infinity. So we're saying our values of x need to be what? Bigger or smaller than negative 1? The other way around, yes, because we're going from negative 1 to positive infinity, so the numbers are getting bigger. So the x, should it be bigger or smaller than negative 1? Bigger, because we're going to bigger numbers, yes? So x should be what? Greater than negative 1. Would we use greater than or equal to for this one? Because let's look at the symbol next to the negative 1. Is it a parenthesis or a bracket? Parenthesis, so can it equal the negative 1? Because parentheses is not included, bracket is. Since it's a parentheses, it won't be included. We can't say that that x is equal to negative 1. It's just going to be greater than it. Questions on how we got our two statements? Since we had or before, we still need it. Now we're just missing the rest of the set builder notation, yes? So again, what number types are we talking about? We're talking about the set of all real numbers, yes? You know what? Let's use the statement we already have because it'd be brace x bar. Because since it's the set of all real numbers, we have brace x bar, the set of all real numbers, such that x is less than negative 1 or x is greater than negative 1. What are we missing? There's one thing we're missing to finish this off. Yep. We just got to close it off. That's it. Sounds like there should be a lot more to this, isn't it? Because we satisfied the two parts, the number type, the set of all real numbers, our brace x bar, and we have our description. That's it. Questions on this here? Now, if you need to, you don't have to, you could actually draw the number line. Especially if you're struggling or having trouble figuring out what the inequalities are going to be. It's sometimes nice to actually graph it out so that we can see visually what we're looking at. Now, if we look at the one on the left, we're starting at negative 1 and going to the left because it's everything less than it, yes? So we'd have the open circle we would shade to the left because it's just going from -1 to negative infinity. -1's not included. We would leave it open. Now we can look at the second part of this statement. We're going from -1 to positive infinity. Oh, okay. So we're still at -1. It's still not included. And we're going to shade to the right. Now something interesting is occurring here. Because we shaded everything to the left of -1, and we shaded everything to the right of -1, yes? So we've really shaded in the entire number line except for what? -1. So for this here, we could really say we have all the numbers except for -1. So we could actually condense this down. Because we can say the set of all real numbers such that, so brace x bar, such that x is not equal to -1. Those are saying the exact same things. Because if we notice the fact that we have everything but -1, we can list it as such. Now, not every or statement we can condense this way, but some it works out that we can. Questions on this here? Are you ready for part C? I don't think there is a part C. I think you just go straight to 6, 7. Let's look at number 6. So we have -infinity to -1 or 1 to infinity. Now, unlike the last one, the two ends of these two unbounded intervals aren't at the same spot. So most likely we're not going to get to condense it down to x is not equal to, because there are numbers, a good number of numbers between -1 and 1. But we do need our two inequalities. I always start with the one on the left. It really doesn't matter. So we're saying -infinity to -1. We're wanting all the numbers that are less than -1 for sure, yes? So whatever those numbers can be, we're going to signify that with x. These values have to be what? Less than -1. Now, could they be equal to -1? Yes, because we have that bracket signifying that the -1 is included. Because we have this bracket here, we're saying that those values that work for this part of the statement can be less than or equal to -1. -1 is included, bless you. Or, questions on this first part before we move to the second part of it? Second one, we're going from 1 to infinity. So for these values to work, or for the numbers to work for this part of the statement, they have to be what? Bigger than 1. X has to be greater than 1. Now, could this one be equal? Could we include 1? No, because we have what? A parenthesis next to it. So it's saying it's not included. Have we written both of those intervals as inequalities? Yeah. We have the description part of this, yes? Now we just need to set it up. So brace x. Again, so what types of numbers are we talking about? All of them, right? Intervals are all real numbers, so we just have brace x bars, the set of all real numbers x such that x is less than or equal to -1. Or x is greater than 1, brace. And that's it. Questions on this here? We're going to look at number 7. The set of all integers except -4. So this one here is a sentence. We will have to write it as an inequality. But they do give us are just types of numbers, or groups of numbers we're talking about. We're talking about the integers, yes? Okay, now let's look for our description. Except -4. So we could have any integer but -4, yes? So that's telling us that whatever x is, it cannot equal what? -4. Now we just need to set up the rest of it. So our group, x, is an element of the what? Integer. So our z with an extra line, x is an element of the integer such that x is not equal to 4. For all values of x in the integers, x is not equal to 4. That's it. Questions on this here? All right, we ready for the next one? And really the next three are very similar to each other in a certain way. Now with these here, we're going to pick between listing it out and writing it in set builder notation. Because if we can list them out nicely and it's doable, we'll list them out. If we can't, then we're going to go to set builder. Because if we look at this first one here, the whole number is 50 through 54. What is our first whole number here that would be listed? Yeah, 50. What would be the next one? 51. The one after that? 52, 53, 54, 55. Is it doable to list those out? Yeah. So that's all we'll do. Oh, just 54. I don't know why I went to 55. That's what I get for not looking at it. But that's it. That's all we have to do. We listed all the whole numbers, 50 through 54. Done. Because this here, we can easily list them out. We don't have to write it as set builder notation. Because we can. Our number type is whole numbers. Our description is 50 through 54. If we wrote our description out, our two endpoints are 50 and 54. Now, because we're writing it as an inequality, inequalities have to have variables. So we have the variable. We're saying the number has to be between these two. Now, 50 is going to be less than or equal to x. It's going to be less than or equal to 54. Whenever we write these inequalities, we make sure that they're all opening to the left. And now all it's missing is the description, or our number types. X is an element of the whole number such that 50 is less than or equal to x is less than or equal to 54. Was it any easier to write it in set builder than actually list it out? Not really. It was almost easier just to list them out for these whole numbers because we can, and it's a little bit simpler. Especially on the first two homework problems, you can just list them out and use the ... We can set a pattern. That's it. Questions on A before we look at B. The real numbers 0 through 4. Well, if we went to list this out, the first number would indeed be 0. Then the next number would be, well, 1 would come eventually, but this is the real numbers. We went over this a little bit yesterday, didn't we? So trying to list the real numbers from 0 to 1 is not doable. There's so many numbers between 0 and 1. It's a Herculean effort to try to get all those, let alone trying to list all the numbers from 0 to 4. This one here, it's going to be better to use our set builder notation because we don't have to list every number between 0 and 4. This will do it for us. Now, since we are talking about the real numbers for set builder notation, we're going to have that brace x bar. Now we need a way to describe it. We need our description. So our 0 through 4. So we know the smallest number is 0, and the other end is 4. This is a bounded interval. We have 2 endpoints. Since we have 2 endpoints, we list them. Unbounded, as we did already with those, we don't include infinity or negative infinity for intervals, or not intervals. Intervals, yes. Inequalities, no. We don't list negative infinity or infinity in inequalities. That's as our x is greater than x is less than it tells us it's going there. With bounded intervals, with inequalities, we have our 2 endpoints. X is in the middle. So here we're saying that 0 is less than x is less than 4. But 0 and 4 would be included. So we have that equal to sign. Kind of just almost the exact same thing we had above it for 50 through 54. Questions on this here? Questions on anything we've done so far? Yes. Yeah. Need both? No, you don't. Now, if it's specific, because here it's just said we're writing it. We want to list it. Either's fine. If it specifically says write the following in set builder, we want set builder. If it just says list it, let me see. Yeah, so set builder is this. The top one is just listing. If it says just list them, that's all it wants. I will take 5 and 6, it says to list, but I will take set builder or the list, either one, because this is writing it out. The bottom one is specifically set builder. If it does ask for set builder notation, we want the bottom. If it just says the list, I will take either one. Does that make sense? And most of the time, especially if it's not really doable or not, it doesn't make sense to do it, we're going to default to set builder. Or you can do the ... Let's look at this one here. The integers, negative 100 through 100. Well, the first integer would be negative 100, yes? What would the next one be? Yeah, negative 99. And then negative 98, then negative 97, negative 96, negative 95, negative 94, negative 93, going on all the way to 100. I would say that's not realistic to try to list all those out, because that is going to be 201 numbers we would have to write out. I say that's way too many, yes? Now, even if we wanted to list it with the ... normally we use that to signify that the pattern continues forever. Here it ends. So it is doable to do that, but we normally don't want to do that. Because if a pattern continues on forever, we can use the ... list it just fine. But especially if we have an endpoint, we can do it that way, but normally we would do for this here set builder. Because here, brace x, our description is what? X is an element of the integers. We have x is in the integers. X is an integer such that what? Negative 100 is less than or equal to x is less than or equal to 100. Because we always want to list it from left to right. We feel good with this here? Okay. You ready for the next problems? Yep. So that's the end of the note sheet. So the homework problems, 5 through 14, 17 through 24, 26, 27. So all of those are the homework. So 5 and 6, the first two problems. It says list the numbers. So we want to list the set. So you can list it using our braces and just list the numbers out, dot, dot, dot. Or you can put it in set builder. I'll take either one. 5 and 6. Problems 5 and 6. Because it says list, use the braces to list the elements of the set. So you can use brace, put the first number, go out a few, and then dot, 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 set the pattern. Brace X element of, or brace X bar if it's all real numbers. 7 through 14, write each of the intervals in interval notation. So that's our brackets and parentheses with commas, our two endpoints. So those there will not have a variable X, but we will have our infinity, negative infinity intervals. We have infinity and negative infinity included. We don't have it in inequalities. And then our next one, 17 through 24, 17 through 20, graph each of the following. So it wants us to give the graph of it for 17 through 20. 21 through 24, 26 and 27, it wants us to write out the given information in set builder notation. Okay. You do have the rest of the class time to work on that. If you do have